Good morning everyone. So in this video, I will explain about the miniature we made, which is the Antalya Expo 2016 Observational Tower. So this Antalya Expo 2016 Observational Tower is part of the celebration of Expo 2016 in Antalya City, the biggest fair in the world ongoing since the 1851. So the tower is about 120 meters, and then the stairs arranged for seeing sight of Expo is placed like a mountain path. We chose this illustration or this tower because the connect section that have been assigned to us is ellipse, and since this illustration is like an ellipse, something like ellipse, yeah, and then this is the actual photo. This one, it's like something that is elliptical, yes, and then circulation elements can act as urban focal points outside of where people can come for a walk and sightseeing. The symbolic observation tower is conceived as a round arc of steel structure with an open-air stairs at its body. The open-air stairs contains flexible walking paths and terraces which are accessed via bazaar entrance. For the miniature we've made, the height is about 20 inches, and then bored at the ground, which is 1.7 inches, and then the elliptical metal frame is about 1 inch and a 12-inch width. Then the elliptical frame and stairs are made of plywood and tire wire as a pole that holds the stairs, and wood and plywood as our base inches. So in our miniature photos, here are the front. This is the illustration. This is the actual photo of the miniature in front, and this is the back, and this one is the side, and this one is the other side. So we've made this miniature by using the materials. These materials, we have plywood, tire wire, plain sheet, paintbrush, disc, artificial plant, stick, lead, soldering paste, wood, soldering machine, nail, glue, glue gun, shoe glue, ruler, and scissors. Of course, we cannot make the miniature without sketching it first and then graphing it using handmade and then computer generated. So here are the sketch, handmade. This one, my one member did this, and then the handmade, this one, and then the sketch, which is the computer generated, and the Dismus, we use Dismus here. Then the graph, computer generated, we also use GeoGebra. We have here now the equation, so I will read. Antalya Expo 2016 Observational Tower Miniature is a vertical ellipse. Our center, which is at the origin, our HK. So after measuring the minor axis, which is 14 inches wide, and the major axis, which is 20 inches, we solve for the value of A. So the value of A is it will become 10 units since it is 2A. So 2A divided by 2, and then 10 divided by 2, it will become 5. And then we solve for the B, center to co-vertex, which is equal to 14, and then 2B is equal to 14 divided by 2, cancel 2, and it will become 7 units. So since we already have the value of A and B, we can now solve for the value of C. So center to focus. So since we have the value of A and B already, we can now solve for the C. So what we're going to use is the square root of A squared minus B squared, which is this is the formula, and then let's just substitute the value of A, which is 10, and then the value of B is 7. So 10 times 10 is 100, and then 7 times 7 is 49. So square root of 100 minus 49 is square root of 51, and then approximately the value of C will become 7.14. So our value of C is 7.14. So since we have the value of A and B, and we have the origin, which is the center, H and K, And we can now find the standard equation of our vertical ellipse. So the formula for the vertical ellipse is x minus h squared over b squared plus y minus k squared over a squared is equal to 1. And then let's just substitute the value of our center, the hk, which is 0 and then the b, which is 7, and then the a is 10. So our standard equation will become x minus 0 squared over 7 squared plus y minus 0 squared over 10 squared is equal to 1. If we're going to find the general equation form, it will become 100x squared plus 49y squared minus 4900 is equal to 0. Why? Because we just solve for 7 times 7, it will become 49, and then 10 times 10 is equal to 100, and then x minus 0 squared it will become x squared, and then y minus 0 squared it will become y squared, and then just copy negative 1 equal to 1, and then we will find the common the less common denominator. Since wala silang common factor, it will become we will just multiply 49 times 100 and it will become 4900, and then just multiply and it will become 100x squared plus 49y squared is equal to 4900, and then just transfer 4900 so that it will become 0, and then the general equation will become 100x squared plus 49y squared minus 4900 is equal to 0. So this is our general equation. This time our main focus here is to get the distance or the length of the defected pole that 2 inch to the right from the center. But first, before that, we have here the situational problem. So a civil engineer went to Antalya Expo Observational Tower with a height of 18 inches wide, observed that one of the poles in the observational tower has a defect. As a safety response, he decided to change one pole, and he wants to take one apprentice to be part of the project. He gave an illustration showing the tower with an elliptical shape surrounded with a metal frame. So as like what I have told you earlier, we will find the length of the defected pole, the 2 inch to the right from the center. We will solve for the problem. So the problem is to find the length of the defected pole that is 2 inch to the right from the center. So to solve this problem, we are going to relate the situation into a graph and use its equation. So we are going to find the value of y using the equation below. So since we have the value of x, which is 2, we can now just find the value of y directly. So we will use this equation, x minus h squared over b squared plus y minus k squared over a squared is equal to 1. And then now using the equation, we will find the value of y when x is equal to 2, like what I have told earlier. And then let's just substitute the h and k, which is 0 and 0, and then b and a, it will become 6 and 9. And then 6 times 6 is 36, and then 9 times 9 is 81. Just copy, and then x minus 0 squared is x squared, and then y minus 0 squared is equal to y squared, and then just copy the 1. And then we have, since we have the value of x, which is 2, we will just substitute the value of x here. So it will become 2 squared, and then 2 times 2, 2 squared is 4, and then it will become 4 over 36. Just copy y squared over 81 is equal to 1. And then the simplest form of 4 over 36 is 1 over 9. Just copy that second term and then equal to 1. And then it will become y squared over 81 is equal to 1 minus 1/9, since we transpose the 1/9 in the right. And then let's just multiply it by 81, and then it will become y square root of y squared is equal to square root of 72. Then it will become y is equal to 6 square root of 2. Then we use the distance formula, which is x squared minus x sub 2 minus x sub 1 squared x plus y squared minus y sub 1 squared. So it will become square root of 6 square root of 2 minus negative 6 square root of 2, and then the value of y here, it will become 16.97. So therefore, the length of the deflected pole, that is 2 inch to the right from the center, is 16.97 inch.